Hi, in this video I will demonstrate how you can solve StackCookie 3. I will not go over the entire solving sequence, but I will give you enough tutorial for the guessing the last one byte of the StackCookie to give a hint to uh, guess full 4 bytes of the StackCookie by yourself. So let's check the binary first, and then it says the stack canary found, so it is compiled with the GCC propolis. And if we can take a look at the code, then in the main function it runs a non-main function. And then in the non-main function, what it does is it's set as I as a 2000, and then it will say 2000 trials left, and then fork, and then the PID 0 means the child process. In the child process, it will run input function, this function, yeah. And then what it does is it asks about how many bytes do you want to read. So send the size as a long integer, unsigned integer, and then in the buffer, it will read the exact size. So we can control the size of the bytes that the program will read by supplying the value to here. Yeah. Then it will read exact byte so that we can overflow the buffer to the exact point of the last byte of the stack cookie, and second last, third last, yeah, fourth last byte, and then guess all the stack cookie, override that, and then run the shell. So we can definitely do that. Yeah. And that's the one of the control. And then what it does is it will fork and then exit, and then it will wait for the child exit. Then the parent will go back and then fork again. So you will have up to 2000 trials. So for the 4-byte guessing, we need 1024 trials at maximum. So 2000 times is enough time. So your task is try to guess the stack cookie value, because when it does fork to create a child process. So fork actually clone the process, and then child runs this part while the parents waits for the child and then keeping the loop. That means all the environment of the parents will be copied and cloned to the child process, and the stack cookie will be copied there too. So in the input function, it will have the same stack cookie value across all the instances. So your task is to guess the stack cookie value byte by byte, and then overflow this to exploit the buffer overflow vulnerability here and running the shellcode. And then to take a look at this more conceptually, so this is mimicking the server scenario, and then the fork means it will copy the entire environment to the child process. So the stack cookie value will be the same. Next fork and the other fork, all the fork will store the same value, same stack cookie value to the server's value. And in that case, what we can do is we can overflow the buffer, and then from the program, we can set how many bytes the program will read. So we can read up to exactly 1 byte more than the buffer. Then we can overwrite the last byte of the stack cookie, but nothing else. So in that case, if we detect stack smashing, then increase the value, and then eventually, if we match the value, then it will not printing the stack smashing error or something. So that's how we can guess which one is the correct stack cookie value, and then we can move forward to guess nether bytes. And then let's do that in our exploit script, and then I will just copy the script from the stack cookie 2. Yes, we will reuse the shellcode, and then we don't need this shellcode and environmental variable part. Then our shellcode address will be the same. We don't need this part. And then before start, we need to get the buffer address or something. Yeah, buffer size. So in the input function, we have a read function here, and the buffer is at EBP minus 8C, and the stack cookie is at EBP minus C. So this part are part for the stack cookie. And then you can also see that at the head of the function, right? So what we know is the buffer is the EBP minus 8C. So we will draw the buffer at 8C, and then stack cookie is stored at the 0x8 EBP. So stack cookie is EBP minus 0x8, 0xC. Sorry about that. Yeah. Then the buffer size is 0x80. Then we have a stack cookie, and then 4 more bytes. C 840. So EBP minus 0 is EB. So this is EBP minus 0, and then this is EBP plus 4. Okay. Yeah. So what you can do is we can fill up to 0x80 bytes, and then guess 1 byte stack cookie here. And then before doing that, we need to know whether current stack cookie. So we can, if we send this to the program, then we can know the result. And then before going to that direction, let's try to run stack cookie 3 first. Then it will tell us like how many trials left, and then how many bytes want to read. And then right now we want to let the program read 0x80 plus 1, which is 129. So 0x80 is 128. So push that. Then put lots of bytes and see what it says. It says stack smashing detected, and then return with the access status with the 134. It kindly print out the access status, but if we don't do weird thing, then it will print out access status 0. So by checking the access status, we can detect stack smashing if it is non-zero, but if the access status is 0, then that means like the stack cookie value has been matched correctly. And to do that correctly, let's match the input and output. So we have these 2 lines are coming from the, so it will print out 2 lines, and then after we type the length, then another line. After typing the value, then it will print out something like this. So the printout from the program, because we want to catch the access status of the program. So we need to read the program input, output, and then process that. And then this is our input. Then it has a new line because we send it as a send line. So we can change it as a send. This is important. If you do send line, then it will send 1 more byte, and then you do not wish to do that. Yeah. So this is like a trial line, and then this is how many bytes. Then for our convenience, we can strip it. Yeah. And then what we will do is we will send, we want to read 129 bytes. So that's actually a string 129, right? Then it will print out reading 129 bytes. Then you send the buffer, and then it will print out some of the lines. So it will print out hello something and exit status is 0, or hello something terminated, then exit status 0. So what we want to do is like just checking the exit status. Then what we can do is so we will read the line until the line does not have an exit, and then exactly when the line has the word exit in the line, for example, exit status, then it will stop reading the line. So we can definitely find the exit status from the line, and then to get this value, what I will do is, so line.split, I will split this by colon like this, and by doing that we can cut the string at here, and then the second item is the 0. So what we can do is strip it and then change it to the integer. So we stored that as a return value. And then if return value is 0, then this is a correct guess. False guess. And then so I will print message here. Then let's run this with any kind of character. For example, we can just put 0x41, which is a character A. So we guessed, right now we are guessing the last byte of the stack cookie as a 0x41, the character A, and then try to run it. My bad. So we will get the second item and then strip, right? So it says false guess. The reason is we will print out the line. Then we send this much byte, and then at the end we overwrite the last byte of the stack cookie as A, and then status smashing detected, printed, and then exit status is 134, so it's a false guess. But if we put 128 as length, which does not overwrite the last byte of the stack cookie, then its exit status is 0. Yeah. No, this one, its exit status is 0. Yeah. So by checking the exit status, we can check if the value of the stack cookie is correct or not. But interestingly, always the last byte of the stack cookie is 0x00. Yeah. The reason is it's to cut off the ASCII values. So for example, if you use a string-related function, string copy or sprintf, those kind of the functions, there were too many vulnerabilities caused by the buffer overflow caused by those kind of the string function. So as a defense to cut off the string, stack cookie will always have the last byte as a 0 for 64-bit and even for the 32-bit, because to match the stack cookie, you need to put the null byte in that sense. But the null will terminate the string, so it will safeguard overriding the buffer in using the string function. But in our case, we are using a read function, which is a binary read function. It doesn't care about the string, and then it will read up to the bytes that we specify, or like the sum of the EOF signal. So it doesn't matter, but 0x00 historically, yeah, it defended some of the attacks, even if like the program has different vulnerability inside with the string related functions. So now we know the first byte, the last byte of the stack cookie. Then we will guess the second last byte, and then to guess that, how we can do that is that we will loop for the I equals 0 from 256. So for each byte of the cookie, we will send 130 bytes, because we will send another 1 byte. And then P8 I, because we will guess the second last byte. Then, depending on the return value, it will tell whether that is correct or not. Then, when the correct guess is found, then we will print out the byte value I. Then, let's run it. Then it runs for multiple times. Oh, all the guess was false. I don't know why, but let's try it again. Yeah. So let's guess then the last byte first. Yeah. No, this is somewhat weird. Let's take a look at that. So X is status 0, correct guess 0. Yeah, I didn't break it. So for example, if we found the correct guess, then I will break. Yeah. So I told you the last byte of the stack cookie is 0. So at the first trial, I equals 0. Then we saw the X status 0. So we can safely assume that first character is 0. Then we don't know about the second character. Then I will increase the size as a 1 more byte, because it will read up to this point. And then I will run this. Then at some point, yeah, it has a correct guess as 163. So in this case, the second last byte of the stack cookie has the byte value 163. And to check that, I will run this again. Then the random value will be changed. So it will not stop at 163, but stop at some different point. Yeah, 214. And then because the value is random, it will be keep changing. So 124, right? 163, right? So by having this kind of the script, yeah, you can get the length of the buffer and then where the stack cookie is, and by attacking this kind of the programming interface. So you can supply the size, exact size, up to the buffer, and then last byte of the stack cookie, and then that's always 0. And then if you guess second last byte, third last byte, fourth last byte, and then write an exploit chain at the end of the multiple of this loop, then you can guess the correct stack cookie value. And then I have a full exploit ready at here. Oh, I prepared an exploit script for you, but I will not show that. But by following how you can guess the last byte of the stack cookie, you can chain it up to the 4 bytes, and you can do it. And then to prove that it will work, I will show my exploit. So it guesses the first character. So it got cookie 0 at the byte 129, and then it will try byte 130 bytes, and then got the stack cookie value as a 153, and then 131 bytes, and then the next byte, and then 132 bytes, and then last byte, and then try to run the exploit. Then now you can see that it will run the shell, and it got the privilege correctly. So by guessing the stack cookie value, so the guessed value is a 0099NG and 4 bytes like this. And by exploiting the nature of the fork, you can check if that your current guess is correct or not. And by using that, you can run you can match the stack cookie and then execute your shellcode to get the shell out of it.